Evaluating numbers with rational exponents. So how do we evaluate when a number has a rational exponent? And as explained before, a rational exponent is a fraction as an exponent. So how do we do this? We are going to use a method called the root power flip method. And why? Because it's the easiest way to do it. You could do power root flip, you could flip power root, all this stuff, but it's not gonna be as easy. And I'm going to explain what that means. So we learned in the last video that 81 to the 1/2 power, if you were to write that as in radical form, this is an exponential form, right? Because it has an exponent. If we were to write it in radical form, you would get 81 to the first power inside of a square root, because remember that 2 is your root. So 81 to the 1/2 power is the same thing as saying the square root, right, because that 2 goes right here, of 81 to the first power, right? So in easier and more simpler terms, it's the square root of 81. And what is the square root of 81? Well, the square root of 81, simple, is 9. Okay, well, that's easy, but something like this may not be as easy because we have that 3. So here is what is not the easy way to do it. So if we were to just put this in radical form, you would get the square root of 100 cubed. Then you have to take 100 cubed, and then you have to take the square root of that. 100 cubed is a big number. So instead of doing that, we're actually going to do it in a different order. And that is where root power flip comes in. So here, let's just make it very clear that when you say something is to the 1/2 power, it means take the square root of it. If I were to say, what is 27 to the 1/3 power, it's the same thing as saying, what's the cube root of 27? And that's 3. So to the 1 over a root, it is saying, what is the square root, cube root, 4th root, 10th root of that number? Here, we are actually going to split this up. And that is where root power flip is going to come in handy. So we're going to do root in red, power in blue, and then flip. But flip only comes in handy when we are dealing with negative exponents, and we will talk about that in a few minutes. Now, we're going to do root and power first. We are going to take the root, then we are going to raise it to a power. What do I mean? I'm going to rewrite this. I'm going to keep the same base. And instead of writing it as 3 over 2, I'm going to write it as 1 over 2 times 3. Now, if I were to just multiply these together, right? 3 times 1/2 is 3 over 2. So this is the same exact thing. But when I split this up, it makes it easier to evaluate because, well, let's see what happens. 100 to the 1/2 power is what? What's the square root of 100? This means the square root of 100. So what is the square root of 100? The square root of 100 is 10. Oh, this should be a 3. Is 10, and 10 cubed is what? 10 cubed is 1,000. So that is your answer. Let's do another one with root power flip, but there's no flip here, just root power. So here we have 27 to the 2/3 power. Well, what is my root? What is my power? Well, my root is 3, my power is 2. So I'm going to split this. Same base, 27. I'm going to raise it to the root of 1/3. Remember, the root always stays in the denominator. It is not cubed. It is to the 1/3 power. Then we raise that to what? The power of 2. And then we go from the inside out. What is the cube root of 27? Again, this means cube root of 27. which is 3. And then we raise 3 to the second power, and 3 squared is 9. Now we could do it the other way around, right? If you were to do 27, you could square it first and then to the 1/3 power. Anybody here know what 27 to the squared 27 squared is off the top of their head? Yeah, me neither. So that would just get really annoying, and that's why it's easier to do it this way. You deal with really big numbers doing it this way, so that's why you don't want to do it. Let's talk about what happens when there's a flip, or when does a flip happen. Well, we have 8 to the negative 4/3 here. So we spoke about in class how negative exponents mean that you flip. Right? And we're going to talk about when we flip, but we're not going to flip right away. First, we are still going to do root, power, flip. So root first, same thing. So we're going to stick to our same base. We're going to raise it to what root? 3, so 1/3. Then what is my power? My power is 4. So I'm going to raise it to the 4th power. And then we have a third one, and it is going to be my flip, which is just -1. If you multiply all of these together, you should get this, which you do, -4/3. And then you work from the inside out. So you have the cube root of 8. What is the cube root of 8? Cube root of 8 is 2. Then we have to the 4th power, and then we have to the -1 power. Make sure you bring everything down with you. And then we go down. So 2 to the 4th power is what? What's 2 to the 4th power? 2 to the 4th power is 16. To the -1st. And 16 to the -1st is what? 1/16. There's your flip. Final answer. Let's try another one. 16 to the -3/4 power. Root, power, flip. Here's your flip. Here's your root. That's too big of a marker. Let's try again. 4. And then here's your power. So there's your 3 things. So let's write it out. We have 16 to the 1/4 to the 3rd to the -1. All 3 of these should multiply to the exponent, which it does. Square root. 4th root of 16 is 2. 2 cubed and to the -1 power. Just bring everything down with you. Then you have 2 cubed. 2 cubed is 8. 8 to the -1 power. Excuse me. 8 to the -1 power is 1/8. There's your flip. Last example. Do this one on your own. Here is the solution. You should have gotten 1/100 as your result.